Hello there, and welcome to everyone joining us for this latest IoT Central webinar. I'm Clive Maxfield, everyone calls me Max, and I'll be your host. In addition to being a practicing engineer myself, I also act as a technology consultant, author, speaker, and educator. I'd like to start our webinar today by thanking Telit for sponsoring the event. Telit is a leading supporter of the IoT Central community, and we're grateful to have them as sponsors. Today's webinar is entitled Connected Machines, Everything You Need for Complete Industrial IoT System Management. Before we begin, I'd like to briefly review the format of today's proceedings. This event will be 1 hour long. We have one presenter who I'll introduce in just a moment, and there will be a Q&A session after the presentation. Please feel free to ask questions at any time during the presentation using the questions feature in the control panel. I will be posing these questions on your behalf during the Q&A portion of today's event. Now, I'm very pleased to introduce today's speaker, Bill Dicus, who is the product manager at Telit. So whenever you're ready, Bill, you can take it away.
Good morning, good day, good afternoon, everyone. Thank you for attending this session. Today I'm going to talk a little bit about connected machines and what that means in the context of IoT, but more importantly, the connection of machinery so that for data and building next-gen applications, whether it's to help your business make money, optimize its business, or add new levels of compliance to your business processes. So let me start by introducing Telit. We are first and foremost an industrial IoT company focused on 3 main product areas. Many of you may know us by our cellular module business. We utilize the best cellular radio technology in the world and combine it with unique packaging and carrier certification to enable you to make your products wireless. So also we leverage the worldwide carrier networks for connectivity, meaning you're able to now transport data from those devices utilizing those networks, but managed and purchased through us with our SIMs and data plans. And lastly, the area that's most important to me is the software and platforms area, where we help you manage the data, the devices and data flows from those devices to your applications. So in quick summary, if you're trying to make a product wireless, leverage our modules. If you now need to transport data from those finished products, we have the connectivity service. And then if you need to help complete the closure of the data and the data orchestration from those devices and managing them to your finished application and within the context of your IoT system, we have that through our software and platforms group. We are awards winning. Of course, we've been very successful amongst the world analysts and researchers that have seen what our platform and our products can do. So we're very proud of what we've accomplished and just want to make sure that you are aware of our accomplishments. So as I said, we are focused on the industrial IoT space. This particular chart has a lot of words on it, but what I want you to focus on is the idea of factories and in industries, whether it be equipment inside the factories or also elsewhere. It's a very big space, and this is where we're starting, where we see some of our greatest accomplishments and where we're seeing people working to connect machines for their IoT and business process improvements. And in particular, it's very much focused on operations optimization and predictive maintenance. But there's also one thing that's not on this list that I'll tell you about in a couple of our customers, how they're enabling their customers through the connections of their machines to their worldwide applications. So Suffice it to say, it's a very large number. But what does your factory look like today? And in the context of machinery, there's a lot of things on this floor. Some of them are quite obvious, but some of them are not. And as this builds, we can see, you're connecting people, you're connecting robots, you're connecting automated vehicles on the floor, as well as the processing tools like PLCs and CNCs that sit in each one of these pieces of equipment. And what's important is that as we start talking about connected machines, not only are they need to be communicating with each other, but there is integration back into what I would call the business process area or the IoT application space. And I'm differentiating in my discussion today between the actual application and the connected machine. And for me, and Telit, everything we're dealing with industrial IoT systems management. And this slide right here outlines the core technology areas or core product areas that you need to have in place to properly run a complex industrial IoT system. So starting at the device, not only are you dealing with the initial connection, you're having to deal with the onboarding, the provisioning, and the constant monitoring of that device, whatever it may be, whether it be a cellular attached laser cutting machine, or whether it's a hard connected PLC equipment on the factory floor. And as I get a little further, I'll show you a slide that sort of talks about the difference between the connected factory and the connected machine, even though there's both machines in both parts. Edge logic, being able to be close to, there's always a conversation between centrally located processing and systems management, in particular cloud-based systems. But in the world of IoT, you need items sitting at the edge, wherever that edge may be. It may be at the device, it may be at the sensor, it may be at the machine, or at the edge, it may be at the factory door. So depending upon your reference point, you need edge logic to help be the starting point for orchestrating the data between the actual device. And data may be data about the device, for device management purposes, or it may be data generated by the device, temperatures, process control, also a wide range of data that's created at the edge by the mere use of a piece of equipment or manufacturing system. It's important for the security, not just the encryption and the end-to-end security between the device and the end application, but also at the device itself and at the systems management level, meaning inside the platform, what are you doing to prevent people from getting access that they don't need to have? So it's important that when you start thinking about, it's not just about the initial connection and the delivery and the connection between the device and the connection between the application. It's about the whole systems of management of the security between those items, including the connectivity services management. In this particular case, we're talking about cellular, but you are having to deal with the whole transport of data from whatever the device might be, whether it be cellular or wireless. What we're starting to see a lot of interest in is the private 5G or private 4G networks that people are implementing or starting to implement inside of factories. And so the ability to work inside the context of those private 5Gs, and then also make the transition between the private network and the public network is starting to evolve and become more and more important. And lastly, the enterprise integration. A lot of discussion around IoT is very device-centric. but more and more we're starting to see the enterprise integration, not just into the traditional enterprise middlewares that we see, that we've had in history, but now a lot of the cloud systems, or even some of the applications that were on-prem are now being moved into cloud areas. So I'm going to use the context of our device-wise industrial IoT platform to talk more about connected machines. But first, I want to give you a little history in particular about our platforms group. It's been around for a lot longer than you may think. It was originally spun off from IBM Industrial Automation into another private company. But in 2013, it was acquired by Telit, and we've been with them and continue to advance our investment in the platform, both at the edge and at the cloud. And those three products amongst the device-wise, the IoT platform is what we're talking about today. Whether it be a cloud service or the device-wise factory edge service, or device-wise for a mobile network operator. So we do, while we have our cloud platform, we do offer it for Telit managed private instances in cases where customers want a dedicated platform. So while I talked a couple slides ago about IoT systems management, that whole infrastructure and framework for managing an IoT system, the edge, the cloud, the enterprise integration, really is about creating the system to enable data orchestration. I started talking about data about the device and data generated by the device. In this particular, so what do I mean by data orchestration? Of course, it means to collect data from the device, or whatever it may be, whether it be a front-end loader in a specific area of the country, or whether it means a laser cutting tool sitting on the factory floor in support of the equipment manufacturer. It's important to be able to orchestrate the data from that system. And what we're showing here is it's not a direct linear path between these different levels of business and OT systems, whether it be control systems very, very close to the process, or whether it's data between production management systems and supervisory control SCADA systems. But then ultimately the data does also move up all the way through to the business systems that are either local or maybe in a cloud system. So what orchestration in my language is extraction and collection. Rationalization. Rationalization in this case means being able to decide what data is being sent. You don't necessarily need the same temperature to be sent constantly if it's not necessarily changed. This is especially true if you're dealing in wireless and cellular systems where you have limited data plans. So then it's important to kind of rationalize what you send. And also, depending upon the type of equipment that you're connecting to, the data form that it's coming out might require some transformation in terms of parsing it differently, getting it ready for ingestion, whether it be ingestion into a cloud system or into a local business system, or communicating to another piece of equipment. Analysis, whether you call it event stream processing or tying with AI and machine learning systems, the ability to properly analyze that data. And that may happen at an edge location, or that may happen at a centralized cloud or bigger system. Some of this can be as simple as thresholds being crossed, or some other anomaly detection, or it may be a visual inspection system where you're leveraging pre-trained picture models to look for deviations from what's expected. And lastly, the ability to integrate and load that data into the business application or the operational management application is critical. Too often, I think people forget that the ability to collect and deliver that data, there's a lot of items happening in between, and most importantly, being able to integrate it and load it where it needs to go is important. And finally, visualization. Being able to present that data, whether it's local to the tools in terms of an OEE application, or in terms of at the highest level at a business tool. So I'm going to use our platform as a mechanism for explaining the possibilities of managing all of those things that I just talked about before in terms of the IoT systems management along with data orchestration in a visual way. And there's a horizontal line there, and I don't want to present it as a dividing line. It's more of an interface line depending upon the connected machine vendor or user of the tools. So let's start, within the context of a connected factory. Usually that's inside of the four walls, and you may or may not need to leverage a cloud system. But as time has gone by, we're seeing more and more applications where on the left side there's a wide range of manufacturing assets, and those assets typically can range from PLCs and torque wrenches and CNCs and robots and vehicles that I pictured before. But it's important to be able to have a high performance connection into that machinery. And in our particular case, we've got a large library that we've developed over time that are bare to the bones connection into machinery. So while we support the traditional open protocols like OPC, which in some situations are perfectly valid for connecting to equipment, our library of direct-to-device drivers enables for a much higher performance connection, whereas OPC typically is a poled mechanism. In high data rate environments, thinking about the equipment that's in the field, whether it be inside of a building or out in the field, the ability to connect to that pieces of equipment in the highest performance way through, for example, through a Telit device driver, which operates in an unsolicited mode. It accepts all of the data that comes to it, and we leverage and we rationalize the data flows after that. So, and then at the other end, when we talked about ultimately the connected machine, being able to get the data from that machinery on the factory floor and deliver it to an enterprise, middleware like SAP, Oracle, traditional ERP systems, manufacturing execution systems. And what makes partially, when you're building a connected machine environment, you have to be able to deal with multi-vendor brands, and that's one of the areas that we're dealing with in terms of the drivers and our ability to communicate with that wide range. And we also talked about visualization in that data orchestration. There's tools to present that. In our case, we leverage our device-wise view, which is a very lightweight HMI/SCADA system for building screens locally, whether they run on a local PC, on a tablet, but that connects directly into our device-wise. So above the line, in terms of the connected machine, we now start seeing our cloud system, the Telit IoT portal, be brought in to help manage things outside of the four walls. And you can sort of see the data. There is some data flow in that yellow vertical line that goes into the portal. In that particular case, it is one method for moving data from the factory floor into the corporate floor. So, and it could run through us. It could be a data at rest, or it could be a data at transit where we deliver it to the application typically in some other business. In this presentation, we're showing to the cloud. And then there is also that same device driver library is also available for industrial equipment that are might be off the factory floor. So let me give a couple of examples here where kind of the idea that a connected machine either is inside the four walls or outside. We have customers that leverage their connected machines like industrial or construction equipment. We have hundreds of thousands of those vehicles in the field connected to our platform. And to be honest, they don't use our edge software, but we are fully capable of working with their telematics system, and whether they want to send it directly to a cloud, or whether they want to send it through us, we can help orchestrate and manage those devices and that equipment. So in that particular case, it's a connected machine that is scattered across the country. They've built applications for communicating data to Salesforce's systems and other business. I'll go into that in a slide later on. In contrast to that, MC Machinery is a laser cutting system that leverages our edge software on our cloud for their remote 360 application. And those pieces of equipment are actually sitting on a factory floor, but the flexibility and the skill for building an IoT systems management and data orchestration for connected machinery, as well as the peripheral applications for viewing data, and most importantly, right there in the center at the top, the secure remote access for remote monitoring and or remote service. So let me move on to the next slide. So, I'm sure you're thinking, well, there's a lot of companies that do this, but in the context of a comparative value stream, we view our ability to go across all of these areas. You see some companies here who do some of the particular pieces of the vertical stack, whether it be data collection, edge logic, the OT, IT integration. And what I want you to think about in terms of when you're building your connected machine system is how much of this has to be built with custom code. And while you may choose a point solution from any vendor, at some point you're going to have to do the custom code and integration between all of those different layers. And something that you previously thought was a buy decision actually ends up turning into a buy make decision, because you're going to have to write custom code between those layers. And so what I want to get across is that we fully have all of these layers of the solution, and there is no custom code to connect them to deliver your connected machine solution. This is just a different lens in terms of how you would think about a whole connected machine solution, the possibilities of the different cloud connectors, as well as the local visualization. And this is an example of one vendor that we work with, and we today have customers who are integrating Cradlepoint as well as other vendors' solutions into equipment and around the equipment. And then we are the system for managing those data flows. So let's do one quick example in terms of a connected machine implementation. In this particular case, in the lower left, we see one plant connecting a wide range of equipment, some of it cellularly attached, and orchestrating the data to traditional enterprise systems, presenting the data locally. In some cases, it might require connectivity and data packages, all being orchestrated through the cloud platform. You're doing remote tunneling for remote remediation, as well as device management. So I started talking a little earlier about one example of a customer who has connected tractors. And in the context of their application, they are utilizing our cloud platform with their own telematics device, but they're leveraging our ability to communicate with those systems across a cellular network, and with 250,000 pieces of equipment scattered across the country, some of the considerations that you have to have are high rates of data flows and individual transactions that are coming in from these systems. And so the ability to, the considerations of any connected machine platform is the data and the data transactions. And like any IT system, OT systems are actually having to deal with tens of thousands of devices. But it's not just the numbers in terms of like the numbers of devices. For example, the laser cutting machine that I mentioned earlier, while it is a much lower number of thousands of devices, it has an application that drives a lot of data flow into the device-wise cloud. So what, in addition to the remote data collection, and as I talked about, the enterprise integration is into multiple systems. It's into a Salesforce system, and it's into an ERP system. It leverages existing AWS cloud services, and also it enables the creation of custom applications. So what's actually happening here? So it looks like a straightforward line, but in terms of the context of a connected machine, you're now enabled to do better product lifecycle management as the vendor of the equipment, knowing how the different systems and subsystems inside of whatever it may be, in this case a tractor, but and then can also enabling custom applications that support the dealer network, who have to provide the service to these equipment. And then lastly, the orchestration of the data in an application to the end user, so that they can know about their vehicle, why, and getting alarms. Why is that vehicle being started up at midnight when it's not supposed to be running, or why was it moved from a particular geolocation? I think it's most important to think of this context of connected machines, regardless of what the machine type be, whether it be a laser cutting tool or a piece of construction equipment or other large industrial equipment. Another example is a oil and gas company that has 3,000 fracking trucks scattered across the country at their individual job sites. So what's the connected machinery there? Those fracking trucks have diesel pumps and motors, and so they're collecting data about the device wirelessly, something that used to have to be done on a what you might used to be called the sneaker net, meaning somebody going around and collecting the data. Now they can collect in real time across wireless networks, so that they can know how well the equipment is operating in terms of is the operational performance meeting what it's required to do, and also knowing what is the actual operational performance. Are they pumping enough? Are they pumping enough slurry? Are they operating over a right period of time? So we leverage both our edge and our cloud systems to help create this whole IoT system to manage the data and orchestrate the data to their business application. So, in terms of the context of IoT systems and connected machines, you have to think across a wide range of application. It's integration with AI. It's the integration with the enterprise systems, doing OE visualization, quality control, so that you can do preventive maintenance. So with that, I'm going to stop and right here, and we'll make some time for some questions.
Well, thanks very much, Bill. That was very interesting indeed. It sparked all sorts of thoughts, actually. A couple of weeks ago, I was in Norway speaking at a conference, and I was on the way there. I was looking at the airport. I was standing in the airport, looking out at all the service vehicles driving around.
Mhm.
I saw a vehicle coming along, and it parked at the bottom, and the guy got out. He didn't take the keys with him. I guess he just left the keys in there.
Mhm.
So and there were all these vehicles lining up. I was thinking, how do they keep track of all those vehicles? And how would they know? I was, idly thinking, supposing I just snuck down the stairs and took one home, how would they know where it was?
Yeah.
Um,
So for example, that exact same situation exists for loaders, for example. I'll come back to that. With hundreds of thousands of vehicles scattered across the country,
mhm.
they really support, first and foremost, their dealer network, so the dealers can know where those vehicles are in support of their end user, and provide predictive services, i.e., hey, we see some alarm codes coming from machine A, and we notice it's on job site B. Do you want us to go out and preempt any sort of failure by that piece of equipment?
Right. Very interesting. I'd just like to remind everyone, there is the questions area in the control panel. So if you've got any questions for Bill, this would be a great time for you to post them. We've got some questions that have come in. I think this is a bit of an open-ended one. What are the standards for connecting to machines? In alphabetical order.
What, pardon me?
In reverse alphabetical order.
There's tons of them. I mean, I think, from J1939 to OPC and MT Connect, BACnet for buildings. We leverage those open standards all the time, but in select cases, we've been able to leverage our ability and our understanding to create higher performance one for select environments, and that is a high value item that we talk about with our customers. You can leverage the open standards, and I will in no way say they've been a benefit to a lot of environments that we operate in. And for example, we are doing a one big connected machine environment, buildings. The BACnet standard for building automation systems, in some buildings that we're working with a client on, has over almost 900 connections to the BACnet driver. So it's a huge, thinking of a building as a one big connected machine, for heating, ventilating, and air conditioning purposes. That's an open industry standard driver that we're leveraging today.
Yeah, one of the things I did notice on one of your slides, where you got this huge range of standards, all the different levels of the hierarchy on the right,
Mm-hmm.
and having a lot. If you're not using device-wise, you have to connect it all yourself, and then
Right.
having device-wise just that goes top to bottom. I mean, that's the one that sold me right there.
That's
and I
been
did
a
have
very important part of the, when we implement these is, I think, the industry, the IoT space has evolved in terms of being able to connect to a specific device type, even if it's a large number, and getting it to one application. But what we're seeing is, in terms of connected machine environments, is multiple device types simultaneously, as well as multiple points of enterprise integration. Because if you're building these, you're building a dealer management network, you're pulling not just data from that device at a specific time, you're now correlating it with when that machine was shipped, who owns that machine, where does it sit, what is its, in many respects, this is kind of the starting point for device twins. What's the legacy of repair of the catalog for that particular machine? And you could replace machine with building, or you could replace machine with. There's all types of machines.
Yeah, I actually had a question on the device management slide where you talked about zero touch onboarding. And in fact, someone's asked the question there. Can you talk a little bit more about zero touch provisioning?
Okay.
Also, is this only for industrial IoT devices, or what are the limitations to use it in an enterprise IoT?
I'm not quite sure what they mean by enterprise IoT, but in the context of zero touch onboarding, we offer a range of implementations, everything from our one edge cellular module, which is pre-configured at the factory for a specific customer, meaning that once that module is installed, it already knows where to boot up to, as basically like a bootstrap server that enables it to then find its pre-configured location within our cloud system, to being able to pre-configure. We have numbers of vendors who are pre-configuring devices, pieces of equipment at the factory to automatically come into their system.
All right. Yeah, I don't know. I can't say unless the guy posted the question, another follow-up. But I was thinking, when he says enterprise, he means not just a factory environment. It could be, like you say, an intelligent building or something. But
yeah,
I know for myself, having tried to provision things, it can be a real pain in the nether regions. So having something that you just turn it on and it goes, hello, I'm here, and the system recognizes it and they all start talking together.
Yeah.
Very attractive. Somebody asks, is DeviceWise a cloud-based multi-tenant platform?
So shame on me for not distinguishing between our edge and our cloud system. So if you remember back to the slide that I sometimes call it our spaghetti slide, where I had a lot of yellow lines that went to different places. In the center, the portal is our cloud-based system. So that is it's hosted on AWS. We have hundreds of customers on it, so it is a multi-tenant system, and it is used to connect to a wide range of things. In fact, you're more than welcome to go to our documentation page, which is docs.devicewise.com, and we have a full. It's our open documentation, and it has the full list of the libraries of the things that we connect to, both on the device side and on the enterprise integration side. But the final part of this answer to the question is that we have also something called DeviceWise Edge. It is a very small footprint piece of edge software that includes both connectors, where I show all that wide range of device drivers to the equipment. It also includes connections either to our cloud or to directly into other cloud and enterprise middleware systems. So you have, and as part of the data orchestration, there is event stream processing built into that software, and it runs on everything from Windows and Linux, something as small as and also, I'm sorry, we're also doing ARM-based chips too. So to something as small as a Raspberry Pi, all the way running up on large AIX systems. So it really depends on how the customer wants to implement it, and whether in the factory floor or inside compute systems that are running inside of a connected machine.
Okay.
And the other unique thing about the edge and the cloud, they can run independently or they can work together. Both from at a minimum level, the cloud can act as a campaign management system for providing software updates to the device-wise edge.
Okay. The person who posed the question about would it also work for enterprise IoT has very succinctly said carpeted space. So that's the difference between the industrial IoT and the enterprise IoT. The enterprise has got carpets, and I think that's a brilliant way of describing it.
Okay. So depending upon what the piece of equipment is, and the network access to it, whether it be cellular or wherever, yes, it doesn't have to be inside of the factory.
What's the difference between IoT systems management and device management?
I think device systems is part of IoT systems management. So device management, as I define it, is actually primarily dealing with the connection, health, and safety of the actual device. Very specific to that. More broadly, I view IoT systems as the inclusion of the data orchestration component, which is kind of bigger and broader. When we've historically talked about device management, we've talked about connecting to a specific device and maintaining the health and status of a particular device. And device management was one part of the whole IoT systems management, which includes the enterprise integration, the security, the edge logic, the cloud logic as it may be required. So it's a little bit bigger topic.
Okay, now when you did the slides, you did talk about device-wise and security-wise, and we said we're focusing on device-wise, but somebody is asking, could you talk more about the security management that Telit offers? For example, does it offer certificate/PKI management?
We are in the process of implementing that today. We have it at some level, but we need to, we are doing more additional work on that right now.
Okay, and somebody else asks, could the URL for documentation be repeated?
Sure. docs.devicewise, devicewise.com.
Cool. Is edge logic the same as artificial intelligence or machine learning?
No. Well, it's inclusive of that. So in the context of a lot of edge logic, it can be as simple as event stream processing, a temperature threshold crossed, or some statistical aspect crossed. To me, AI and machine learning is a very specific tool that is part of edge logic. And what I would say is it typically requires an add-on AI machine learning model that the edge needs to communicate with to help process. So let me give an example. So we've been doing a lot with visual AI and machine learning in visual inspection. And one example of how this works is the device-wise sits at the edge. Say a picture was taken, we act as the orchestrator of the picture to a pre-trained AI machine learning model. And of course, we could have also been part of that initial training. So typically what we're seeing is that in the implementation of machine learning or AI at the edge, the model's been pre-trained as part of some much larger collection of data. You know, it could have been a data lake, it could have been some other subset. Whereas, say we've captured a lot of pictures and they've been trained at the training system level, and then some model has been developed, and then there's a local. And of course, you can do this at the cloud, but what we're starting to see is that the models are located at the edge. And then once it's in an operating state, that the picture's taken, comes in through us, we deliver it to the model analysis, typically local attached to us, and it can be co-located depending upon the piece of system or the size of the system. But it is then marked up, say a wheel's missing a lug nut, the signal or the the markup decision comes back to us, and then we know what to do with it from a business logic perspective. It could be that we send a notification almost anywhere, but in one application, it's sending it to IBM Maximo for a trouble ticket.
Mm-hmm.
So if you think about wheels being inspected going down on an automobile on an assembly line, the wheel could end up being scratched. That gets seen say a picture was taken, it was sent off and marked up, then we can associate the anomaly with the creation of a trouble ticket for follow-up the further down the line.
Okay. How does DeviceWise handle a hybrid private/public 5G environment?
We have done some work with Ericsson. So for example, first off, let me start at the highest level. So our cloud system is typically hosted in AWS. We have that in the United States, and we also have that in Germany, as well as some dev environments and engineering environments here based in the United States. But our production environments are in Europe and the United States. As well as we offer Telit managed private instances to larger customers like a large mobile network operator in Switzerland, and then also a large IoT company in China is running a managed service version of our platform. In the context of the factory, we have also done work with Ericsson and their private 5G network system, and we are doing some work with others. We can completely communicate across. It's almost the same, analogous to all of our Telit systems can run across the worldwide cellular network. So we're not dependent upon. It doesn't really make any difference to us whether it's a private 5G or a public 5G, as long as our device can attach to that network. We can operate across it inside of a private 5G network.
And actually, we've got another 5G question here. Could 5G be the right technology to do real-time monitoring of thermal imaging streams?
I think that's a question I would need to follow up with and bring in some more technical expertise in terms of the performance numbers. Depending upon, first off, 5G is designed for very high speed and very low latency, high volumes of data. I think to properly answer that question, we probably need to see what the data flows are. And if they want me to follow up with them, I'd be happy to.
Okay. Well, we'll have the questions here so that you can drop them an email afterwards. Because my knee-jerk reaction there was, how much data are we talking about? What sort of thermal streams? What sort of resolution? What's frame rate, etc.
Yeah. I mean, we're doing a lot of, one implementation of visual. It's somewhat dependent upon the granularity of how you want to look at the data. So, for example, we were doing work with a high-speed box making line, and one of the anomalies there was if the boards, the folded cardboard boxes are running down the line, and it's super fast. If it starts getting outside of the predetermined boundary, you're at risk of all the boxes flying off the line. So in a discrete way, trying to get a picture of every single box would be a challenge. But we also looked at it from a kind of like a continuous stream that you're looking for. You're seeing, it's almost like a visual trick. You're seeing a line, it's moving so fast, each of those individual boxes look like a singular line. So the trick is more watching, can you respond fast enough to deviations of the box moving through the line? Outside of its pre-configured zone.
I've seen some amazing videos of not a classical robot arm like a hand, but more, it's on wires, but it's leaping around on a conveyor belt that's going at really high speed, plucking things out. Mind blowing. Yeah. Okay, this is with regard to the zero touch provisioning for devices. Is the device-wise agent needed on the devices / gateways?
No. You can use, and in fact, if you go to docs.devicewise, we show in a very succinct picture that the DeviceWise Edge is just one example of the types of products that we connect to in the cloud system. So if you wanted to communicate with, in fact, we have built-in lightweight M2M protocols, and we have built-in MQTT protocols. So it's you can connect any type of device to our system. And also on the same thing, if you do not want to connect a piece of enterprise middleware that we've already developed connectors for, but want to build a custom application, we have published APIs on the let's say the northbound side, the enterprise side, so that you could write custom applications to access through API the data as it's either resting in the platform or as it's flowing through the platform.
The carpeted side.
The carpeted side, yes.
Why do we need both edge and cloud intelligence?
Well, it depends upon the application. In some cases, you do need, in a cellular environment where you're collecting volumes of data, you don't necessarily want to send every piece of data to the cloud because it is either redundant and or will increase the expense of your application. Also, relying on the cloud for low latency situations where you might want to have some edge intelligence to receive the data point more closely to where the data is created for faster access. Again, low latency, have the decision point be made at the edge. It's not necessary for all applications, but it's a valid tool to use in terms of your data orchestration. Mm-hmm. And in some cases, our edge intelligence sends directly to third-party clouds.
Right. So I think you addressed this in one of your slides, okay, or at least you differentiated between them. But should connected machines be isolated from the connected factory?
Yeah, I don't know if I emphasized this enough, but in the slide that had there was a horizontal line for connected machines and connected factories. Up above was the connected machines, and I think the example of the laser equipment cutting vendor is an example where it's sitting inside of a factory. And so what we're dealing with is the actual vendor of the equipment, maintaining either through product lifecycle management purposes or for secure remote access. They might need to be accessing that equipment at the benefit of the vendor, of the factory vendor, so that they can update or maintain that piece of equipment without having to roll a truck. So they are together and they are separate. It just really depends upon the implementation.
Okay. We've got some questions that, to be honest, I think it's more specific to individual companies. The questions are more focused on how can I do this with my particular environment, and I think it's a bit more detailed than we want to get into here.
Okay.
But Bill, you will be following up with all these questions later.
Absolutely. Right? Yep.
So Bill will get in touch with you to answer the more specific ones that might not interest everyone. So I think we've got time for one more question, because we want to be mindful of people's, when we say we're going to end at a certain time, it's nice to actually end on or before that time, not 10 minutes later. While I ask this question, Bill's told me that you can feel free to contact him directly using the contact details that will show on the screen momentarily. So is it mandatory that IoT systems management be rolled out all at once?
No, not necessarily. I mean, although to say that, one of the ones was security. You probably want to roll out security simultaneously, but the other aspects, can be brought together in different phases. And as you typically manage a rollout, your first phases are connecting to, can I connect to this device? What type of data can I get? And in many respects, it's just gonna happen because you're gonna roll out. Okay, can I attach to this piece of equipment? What type of data can I get? Can I get it to where I need it to get? And that's like level one. And then the next thing that's going to happen is you're going to start saying, I either want more data or I want to combine it at the edge. And then I want to, how will I ingest it into the business application? Then it might get more sophisticated over time, and you will be pulling more IoT systems management into it.
I think you're right, though, that you start with security, that you don't just hook a machine up and start broadcasting data out. You set up the security environment, and then you start adding machines. And you might, as you say, you might start with a limited amount of data from one machine, and then start adding more and more data from that machine and other machines nearby, and so on.
What I've found as I've watched our different rollouts with different customers is the initial phases of being able to connect to systems is really, by us, is really amazing in terms of how fast we can do it and how fast we can get things going. And to the point that then our customers spend a lot more time figuring out what do they really want their business application to look at. It becomes less about what I connect to and how I connect to it. But now, as I said, I talked about the data orchestration. They have to figure out how the data that they're going to deliver and orchestrate as part of an enterprise integration. What is the application that they want? Is it a remote support? Is it performance management? Is it creating new separate applications? Is it delivering data into an ERP or an MES? It becomes a data-centric lens that you look upon things.
And I think sometimes people don't realize all the possibilities. They know that they want to start moving into this area, but they don't actually understand all the different things that you can do. Data is king. Once you've got all this data coming in from the connected factory and all these connected machines, the possibilities are almost endless.
The good news is that in the kind of the development phase, things look flat. Like, oh, I've got 100 different devices and we're building the application. But then very quickly, once the rollout happens, whether it's the number of devices or the volume of data, it kind of takes a hockey stick. It just blossoms.
Right. Actually, that leads me back to the one thing that really struck me. I think it was your very first slide when it said Telit's helping connect a new IoT device every 1.3 seconds. And I was like, oh my gosh. Okay, 1 minute to go. So I'm going to have to say this brings today's webinar to a close. I'd like to thank everyone for attending and to give a special thanks once again to Telit for their sponsorship and especially to Bill for his insightful presentation. Once again, this is Clive Maxfield, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on the next IoT Central webinar. And until then, from all of us here at IoT Central and at Telit, we hope you have a wonderful rest of your day.
Thank you all.
Thank you, Bill.